Okay, hello, and welcome to this presentation on Codesandbox and state management. I thought I would just do a recording of it in case we miss out the remote presentation or somebody needs to see it later. I tried to prepare as much as I can here, but I'm going to wing it a little bit, so hopefully it will be okay. Okay, so the agenda here is to talk a little bit about the brief history of Codesandbox, like where I got into the project and even before that. Then I'm going to try to talk about the complexities of Codesandbox, like what is the state management complexity, a bit of an abstract. And then we're going to be a little bit more concrete and talk about the initial refactor that was done and like where the project is today. And then I'm going to talk about the next refactor we're working on right now. Okay, so actually almost 5 years ago, I started this project called JS Fridge. And it's kind of funny, like when I prepared this talk, I found this video I did on it. And it's kind of funny how kind of like conceptually similar it is to Codesandbox. I even have like, it says sandbox there on the URL, which is kind of funny. But this project was a project where you were supposed to write like simple code and do a recording of it directly in the browser. So you could like hit record, write the code, talk into the microphone, and it would record everything. And when you played it back, you were able to pause it, play around with the code, and then press play again to kind of like continue the course. And I think I tried to implement this with Angular. And I had a really hard time managing the state because there was so much client-side state here. And then funny thing is when React came out, I didn't quite understand it. But when they started talking about Flux in Facebook, that made a lot of sense to me. So I tried to take those ideas and bring it into Angular. And I actually have a project called Flux Angular. And that helped me a lot with the state management. I didn't get into these constant situations where I weren't able to access or change the state from specific points in the UI, which occurred a lot in this kind of application. And this is where the ideas behind the Cerebral tool occurred. So this is kind of like where the beginning of Cerebral started. I wanted to like solve this in a better way, and yeah. And then later I was totally into React, and I got a chance to do something with this project. It was a project called Codesandbox in Norwegian, or the Codebox, and I got some funding for it, and I got some help with a little bit of design and a friend of mine to code. And we did it was the same concept, be able to record courses in the browser, and we added video, and it worked pretty well. But the project itself wasn't a success because, well, the project was a success in terms of testing it with users and stuff, but we had no business experience or stuff like that, so we didn't know how to move on with the project. But in terms of implementing it, now Cerebral was a thing. It had a stable API. There had quite a bit of adoption, and it worked really well. So there was no technical difficulty here. It was more of a business thing. So that project was dropped, but later I got inspired again, and I built Webpack Bin. And Webpack Bin was this project where you could run npm packages in the browser. And the way this worked is that whenever you connected to Webpack Bin, a Webpack instance would be given to you on the server side. So the bundling would actually happen on the server, but there weren't many files, so it was insanely fast. And even though memory was a concern, it wasn't a real issue. But shortly after I released this project, and this was huge for me, like it got quite a bit of adoption, and yeah, technically it was a big challenge. But yeah, it was a lot of fun. But then Eves and Bas released Codesandbox, and like I say in the presentation I had on this, I got a little bit depressed initially because when I found out that Eves and Bas was like 19 years old and I was 32 years old at this time, it wasn't like the initial feeling. But I got over it quite quickly because I contacted Eves to ask him how he did things. And when he talked about the client-side bundler, I was like, oh, yes, that's what I initially wanted to do. But I felt it was too daunting. But that's kind of like the thing with Eves. Nothing is too daunting for him. He just dives into it and he figures something out. So I was really impressed by what they were able to do with Codesandbox. And we started sharing ideas. We even had like a shared service for delivering NPM packages to both Webpack Bin and Codesandbox. And yeah, we had like great talks and it was super fun. And then we actually met at the conference. And we like had mentioned before if we should rather collaborate. And I told Eves that, okay, I don't have time for Webpack Bin. You have all the time in the world, being a student who doesn't want to learn Java. So let's close down Webpack Bin and I can rather help you with Codesandbox. And as we talked about, Codesandbox has some difficulties on the client, some performance issues. So if I can get into the code base by refactoring it to Cerebral, that would be super motivational for me. And also I think it is a really good fit because I've been using Cerebral on these kinds of projects before. Okay, so that was like a little bit of history on how we got to know each other. And now I'm going to kind of like try to talk about the complexities of Codesandbox, like from my perspective. And it's a bit abstract, but hopefully it will make some sense. So I'm kind of like applications are different. Like there's not like one perfect way to manage state because applications has different levels of complexity in managing state and the type of state, and there's so many factors here. But I'm just using Facebook as an example here, just to show that the difference of applications and state management. So if you think about Codesandbox versus Facebook, and by the way, I never worked at Facebook. I have no idea how Facebook actually works. Like I haven't seen the code, but I've seen a lot of talks and listened to the React development team and like what are they concerned with and stuff like that. So I think I have some idea of the challenges they have. So anyways, like the challenge of Codesandbox is client state complexity. There aren't much data in Codesandbox. You can like fetch a sandbox and there's some badges on the user or something. No, tag. Yeah, badges and tags on the sandboxes, and there's not that much data going on. So when you kind of like do when we change the state, it's related to something happening in the client. Unlike Facebook, where they have data complexity, everything is about the data. And variations of that data and stuff like that. So in Codesandbox, you can say that the client state changes are like driven. I mean that the interaction of the user drives the client state changes. So for example, when a user changes code, we do a lot of stuff in the client. We don't talk to the server. And that's the case for many of the different kinds of interactions in Codesandbox. Unlike Facebook, every interaction there does something to the server. Like it needs to grab some new data, it updates the data. That's all Facebook does and should do, really. Another kind of complexity I think differs in Codesandbox and Facebook is the side effects. Because Codesandbox has a ton of different kinds of side effects. It's not only talking to the server to get sandbox data. It's like talking to GitHub, to site, to Netlify, npm packages, key bindings, bundling. We have the preview window. There's a notification system there. That's also driven by stuff happening in the client. And of course we have VS Code itself, which also is like one big side effect inside Codesandbox. But at Facebook, I have this feeling that side effects is related to the data. So for example, how to optimally cache and clean out the cache of data. How to optimally load code related to the data arriving at the client. That's the kind of concerns that Facebook has. We don't have those concerns at all, really. At least not currently. We probably will, but yeah. Okay, so that was kind of like a bit abstract. Maybe it made sense to you, maybe it didn't. But yeah, I just wanted to talk a little bit about that. But let's now talk more concrete about the state complexities of Codesandbox, or the complexities of Codesandbox. So when you open a sandbox in Codesandbox, there are actually 21 different state changes and 9 different side effects running related to that. And that's a lot. But what's important to remember here is that it doesn't matter what tool that is defining and manages these state changes and running these side effects. This needs to happen in some way or another. It's just the nature of Codesandbox. So the question is more like, what tool do we best manage and express these state changes and side effects? So initially, Codesandbox was written with Redux, and the challenge with Redux is that with all this complexity in state changes and side effects, things were split up into many different files. So you had like loading a sandbox was actually 10 different files, and you had to visit all of them to kind of like try to build up a mental image of what actually happens when we load this page, for example. And that was the case with all kinds of logic. It was split up into many different files because this is how Codesandbox works. Like if you do something on the right side, it affects something on the left side, kind of very simply put. So what the Cerebral refactor did is that it reduced this to 3 different files, all this logic. But most importantly, one of these files were actually able to express everything that happens when you open a sandbox. And that is kind of like the core of Cerebral. You have this ability to think outside your UI. You just think about all the logic you need to do something, and then you just express it exactly as you want it to run. And on the right side here, we can see that code actually from like a couple of years ago or a year ago or something. And though the API is a bit exotic, it's like it's a functional API. It's just a little bit exotic. And it's declarative. So you can read the story of what's happening here and understand what's happening. And then within each of these actions, there are more logic related to running side effects or doing like complex state changes. Another thing that was really great about the Cerebral implementation or refactor is that we got the development tool. So all the state of Codesandbox is available inside this standalone application that can run next to your development flow. And you also get insight into all the logic that is running. So for example, when the sandbox is changed, you will see all the state changes, all the side effects run and everything. Which is really useful for new people getting into the code base, but also to figure out bugs. So if something bad happens, you can take a look inside the dev tool and just see, did I actually make the state changes I wanted? Was there some side effect running here? Or whatever. So as a summary of this refactor, I think it did an improvement in terms of fixing some performance issues. We were able to clean up a lot of the code, like put the code together instead of splitting it up in a bunch of components. I think it also made it easier to contribute. It's difficult to say because the amount of contributions has increased due to the project becoming more popular. But at least there has been contributions, so it hasn't been like a blocking thing, at least. But again, like Cerebral is not that known compared to Redux and other tools, and also it has this exotic declarative API, which is not ideal. And of course, it does support TypeScript, but not very well. So this is what we're doing now. We want to take another iteration on the code to make it even more friendly for contribution, both in terms of people now working for Codesandbox, but also other people, as the client is open source. But of course, we also wanted to support TypeScript. And so the question is do we refactor back to Redux, which also has matured a bit? And there are some Redux starter kit, for example, that cleans up a lot of stuff. But Redux wasn't built with TypeScript in mind, the API, because it wasn't popular at the time. So it still has quite a hard time managing typing, because you have to write a lot of typing as you're implementing. So you feel like you're telling TypeScript more what your application is about instead of TypeScript helping you. Also, the Redux API, for those who don't know it, is quite difficult to learn. You have the reducer concept, you have a thunk concept, you have this map state to props concept. When you know it, it's all good. I'm not saying it's bad. It's just there's a threshold there. And then we have MobX state tree, which is really awesome. And actually, the Cerebral implementation in Codesandbox now uses MobX state tree as a state store. The thing about MobX state tree though is that it has quite a bit of API surface. It has its own runtime type system, which personally I don't see why it has it, because TypeScript has the type system. Maybe because it was built before TypeScript became popular. I don't know, but it seems unnecessary. And it also has quite a bit of APIs related to actions and views, I think they call them, and stuff like that. But most importantly, it's missing the DevTool experience. It uses the Redux DevTool, but the Cerebral DevTool does show you a lot more information about what's happening inside the application. So then we have this Overmind JS project, which is kind of like the spiritual successor to Cerebral. We understood that Cerebral could never completely support TypeScript because the API is just too exotic. So what we did is that we spent 6 months building a new API for Overmind, where we leaned on the approach of MobX instead of Redux. And we tried to make it an API-less API, and also get a feeling that TypeScript is helping you a lot more than you are telling TypeScript how your application works. So those two things were kind of the leading pillars of developing Overmind. And we spent 6 months iterating the API, and then we released it. And it's running on many different projects, and it has this taken all the experience of the DevTools with Cerebral and put that as well into Overmind. So yeah, this gives us some benefits. First of all, it makes the transition easier, because we can actually use the development tools to verify our refactor, which I will show you on the next slide. And also, we kind of own this state management tool. So if we need to do something, to express things more clearly, we have the possibility to add additional API, or if we get into issues where we do things wrong, we can implement checks, for example, to make sure that people don't do stuff they're not supposed to do. Things like that. It's not just nice to have that ability. Okay, so kind of like conceptually now, the logic is split up in signals, actions, and providers in Cerebral, where signals are like this declarative presentation of the logic, and then we have actions where we do imperative stuff, like we do complex state changes, we run the side effects, and stuff like that. And then we have the providers, which is kind of like a tiny contract between Cerebral and talking to the outside world, like using other tools and stuff like that. Now, these providers are quite generic currently. So, for example, the API provider exposes just like a get, post, patch, put API. So the logic has a lot of magical strings pointing to different URLs, and when we, for example, add a notification, we explicitly say every time if it's an error, and we have to make sure that this error status is correct. And yeah, it's quite low level. But yeah, this is how kind of conceptually the logic works now. And then with the Overmind Refactor, we only have actions. So we don't have this declarative front anymore. We lean on like a more straightforward imperative logic. But there's just a function. Like an action is just a function. The only thing you need to know is that every function, the first argument is all the state, all the effects, and all the actions of the application. And then you start writing your logic. And then we can have like, if there's some shared logic, we can have like an internal action, like an action that is only used by the other actions, which works exactly the same way. There's nothing special about them. But like in Cerebral, there is a lot of actions. So if we jump back here, there's a ton of actions. While in Overmind, we want to reduce the number of internal actions as much as possible. So we either have the logic inside the front actions, or we have them inside what's called effects. So providers and effects is the same thing. But with effects, we are being a lot more domain specific. So for example, the API effect in Overmind is not like get, post, patch and stuff like that. It's get sandbox, get current user, get this, get that. What this does, first of all, is to clean up the logic inside the actions. So there are no magical strings or anything like that. You should always have an API that is domain specific to use when you need to talk to the outside world. Another thing is that we do the typing inside the effect. So for example, when we get a sandbox, the effect is typed with returning a sandbox. So that means that if we would do like API get inside an action, like with the old approach, we would have to give it the type. So you would have a magical URL and you would have just any type you wanted, which could be wrong. So having these domain-specific effects is a really good contract between the logic of the application and the outside world. What it also enables us to do is to change out the effect implementation. So currently we are getting a sandbox using like Axios and doing a normal HTTP request, but maybe we want to use GraphQL instead. We can just change that inside the effect, and the API stays the same towards the logic of Codesandbox itself. And it's the same for like notification tools. We don't only have add. Let's put in success, error, and warning. Like make the logic as clean as possible and rather move the specificities of the effect inside the effect. And the same for like site. We create an effect for site, which enables us to deploy and get deployments and stuff like that. Okay, so the way, like the current state of this refactor is that there's been an initial run where there's been created an Overmind directory inside Codesandbox, where in development mode it actually instantiates Overmind next to Cerebral. And I did a brute refactor of all the Cerebral logic into Overmind and TypeScript. Just going through every single signal, as they're called, inside Cerebral, and just refactoring without testing anything. And the current state now is that we are starting to run the logic. So this is the really nice thing about moving to Overmind, is that we can now use the Cerebral development tool to trigger some signal, either by clicking in the UI or using a special function I'm exposing to trigger a signal. And then we can compare. So we trigger the signal in Cerebral, we trigger the same, like the refactored action inside Overmind, and then we can see, does it do the state changes and run the side effects we want it to do? And that gives us a lot of confidence when we actually do make the transition in the components, that the logic actually works. Because this has been a huge challenge also on the initial refactor, is that there are so many changes all the time in the code base. So we have to find a strategy where we can do incrementally do changes over to this new Overmind tool. Yes, so when everything's been gone through and tested, we will actually flip over to the components. And the strategy there isn't 100% yet, but we might be able to do some trickery where we just keep the API as is, like with the components, and then we kind of like replace the current higher order components with different implementation, so it exposes Overmind instead of Cerebral, or we'll figure that out. I don't think that's going to be a big issue. Okay, so finally I thought I would just show you a little bit of code. So what we have on the right side here is the structure, the file structure. The store folder is the Cerebral implementation, where things are split up into modules, providers, actions, and stuff. And the index file contains the signals. In Overmind, we have effects and namespaces, like effects instead of providers, namespaces instead of modules. And then we have like actions and state and yeah, stuff like that. So what we're looking at here is the sandbox changed refactor. So there's a signal called sandbox changed, and we also have an action called sandbox changed. And this is an async action that takes a string, which is the ID of the sandbox. And then we're using a factory here called with load app. And this is the same in Cerebral. We have some logic we want to run related to mounting certain things like the sandbox or a different page or something. And that logic is related to grabbing the users, setting the settings and all this stuff. And we're just saying that this load app factory should take a string so that these two match up. And that means that TypeScript now tells us that we're getting a string here. We have all the state of the application, we have all the actions, and we have all the effects. So what's changed now is that we don't have all the declarative stuff, we're just implementing. So here we have, like, we're setting some state on the editor namespace. So the thing is, we're always pointing from the root, meaning that even though these actions are inside the editor namespace, it can access whatever state and actions and effects it wants to. And the reason we don't have isolation is because it becomes very problematic, especially in a project like Codesandbox, where we're continuously exploring the domains of the application. It changes all the time. We're exploring and exploring. And if we had isolation, we would be forced to refactor all the time. And also we would have a hard time with sharing state and logic between the domains. Because with isolation, they can't reach each other. We would have to like move a bunch of stuff up to the root domain just because they need access to other things. And the root domain would just be bloated. So we rather structure our code the way we want to think about the code, not because of issues with isolation. Okay, and now we're using an internal action from the editor namespace. So all the internal actions are behind like an internal namespace. So we are just ensuring that we have a sandbox ID. And the reason this is an internal action is because we share it with other pieces of logic. Then we're checking if we are live, and if we are live, we want to disconnect, which is also an internal action. Then we're changing some state, and we are trying to grab a sandbox. So we got our sandbox here, and everything is typed here. And we're checking if we already have this sandbox, and if we do, we just update it. If not, we're setting it. Then we change, we're just resetting some more state. We ensure that we have a package.json file. I'm not sure why this is on the root. This should probably be inside the editor namespace, but this is stuff we can fix when we actually move to TypeScript. And then we're checking some more related to the live feature. So if we want to go live, we can initialize that, or we can recover the files. And again, we have like content mounted, where it's just a simple action where we run an effect. Basically, we want to register an on-unload function whenever this content mounts. And again, we are just checking some state, doing some stuff. So this is basically how everything works. It's just a bunch of actions with the logic right in there. And whenever some logic needs to be shared, we put it into an internal action. Or if the logic is just very bloated, like the action becomes like 200 lines of code, we can also separate it into internal actions, just to separate out the logic a little bit. So if you're coming from Redux, the biggest there was a big mental shift going into Redux, because you had to think about reference checking all the time. Like you do, whenever you change some value, you have to make sure that everything is new. Like if you change the name of a user, you have to use the spread operator so that the user object is also new. You don't do that here at all. You just use the plain mutation API of JavaScript, the way JavaScript works. And I'm not saying like doing like spread operators and immutability and that stuff is bad. It's just that JavaScript doesn't have it. And we don't need to use it to ensure the predictability and constraining mutations within the actions and stuff. We can do that. And also by doing direct mutations, we get a more specific point of change. So for example, if you change the name of a user with immutability, you also change the user. You don't know that you changed the name. But in Overmind, we know that we changed the name, so only the component that actually looks at the name will render again. So yes, okay. But I think this is good enough. I'm going to talk a lot more about this stuff as we finish up the refactor. We'll do a lot more clips and maybe do some live coding and stuff related to the refactor. So hopefully it will be a good time getting into the new client code base. Okay, thanks.